It's time to take a look at question 28 from chapter 7. So the question says a population proportion is 0.40, random sample size of 200 will be taken, and the sample proportion, which we're going to call P bar, will be used to estimate the population proportion. So we have two questions here in question number 28. First one, what is the probability that the sample proportion will be within plus or minus 0.03 of the population proportion? And then we need to find the probability that it will be within plus or minus 0.05. So we'll take a look at part A first. So in order to figure out what these probabilities are, we first need to set up a sampling distribution. So we need our proof. We need to be able to prove that this is normally distributed. Since we're dealing with proportions, our proof needs to be n times p is greater than or equal to 5, and n times 1 minus p is greater than or equal to 5. So if we work out that math, n times p, our 200 times 0.4 equals 80, and n times 1 minus p equals 120. So we're good on both of those as our proof. Now our expected value. Our expected value is just going to be p. So it's just 0.40. Now our standard error. If we take a look on our formula sheet, our standard error shows this formula. Now the second half of that formula, the square root of n or big N minus little n over big N minus 1, that's called our finite correction factor. So if we were given a population size, if we were given a big N in this problem, we could figure out if we needed to use this. So if your sample size is more than 5% of your population, you use that finite correction factor. Here we don't even know what our population is, so we can just get rid of that in our formula. So now we just plug in the pieces that we know. We know that our P is 0.4 and we know that our N is 200. So we plug that into our formula. That will work its way down to 0.24 over 200, and the square root of that gives you your standard error of 0.0346. So now that we've solved each of those parts, we can draw our bell curve and put our expected value on our bell curve. Now, for probabilities, we are going to need to figure out areas underneath the bell, right? So we want to know the probability that it's within plus or minus 0.03. So we put those 2 points on our bell curve, right? We add 0.03 and we subtract 0.03, and we are looking for this area between there. So in order to do that, we need to find our z-scores. Our z-score formula of p bar minus p over the standard error. Our p bars in this case will be the 0.37 and the 0.43. So if we plug those in, we get 0.37 minus 0.4 all over our standard error that we found on the last slide. And we do that as well for the 0.43. We find that our z-scores will be plus and minus 0.87. So now we can use those z-scores, look them up in our table, and when we look up z-scores in our table, we're going to be given areas to the left, right? So if we look up negative 0.87 in our z-score table, we find that the area to the left of that is 0.1922. Now we do this for positive 0.87, and we find that that area is 0.8078. So, in order to find the area between those 2 points, we need to subtract 0.8078 and 0.1922, giving us an answer of 0.6156. So when it's asking what the probability that the sample proportion will be within plus or minus 0.03 of the population proportion, that's our answer right there, that 0.6156. So now we can take a look at part B of this problem. What changed here was just that now we want to know the probability that the sample proportion will be within plus or minus 0.05 instead of 0.03 of the population proportion. So our proof is exactly the same, right? N and P did not change, so our proof still works. Our expected value is exactly the same, and our standard error, once again, because N and P did not change, it works out to being the same exact standard error. So, our sampling distribution is the same as it was in part A. What changes now is our next step. So, we want to now find out the probability within plus or minus 0.05. So now we're looking at 0.35 and 0.45 in this problem. And again, we want to know the area between those 2 points on our bell curve. So in order to find that area, we need to find our z-scores, right? So P bar will be 0.35 and 0.45. We subtract that from our P, the 0.40, and divide it by our standard error that we found previously. So our z-scores will be plus and minus 1.45. Now we take those z-scores, look them up in our z-score table. We'll find that the area to the left of the z-score for negative 1.45 comes up as 0.0735, and the area to the left of positive 1.45 comes back as 0.9265. Again, we're looking for the area between these 2 points on our bell curve. So what we need to do is subtract our 2 areas. So 0.9265 minus 0.0735 ends up giving us an answer of 0.8530.